This is just a brief discussion about crossing the Rockies while there's mountain wave going on. And this is my G1000 data from a Cessna 206 Turbo imported into Cloud Ahoy. And you're looking at the heads-up display with the simulated satellite terrain. And on the left, there's the that graph over there. The interesting piece of data there is the AGL altitude. And on the right-hand side, on the bottom right, we've got the VFR sectional, which is also helpful to kind of orient where we are. So I'm going to start playing this. And this is regular speed. So as you can see on the sectional on the bottom right, I'm approaching the east portal. You can see the words east portal just beginning to appear there. So that's a popular VFR crossing point in the Rockies. It's unfortunately you can't really see it on the satellite imagery as clearly as you can see it in real life. In real life, it's much more like it's a low wall, where on each side of the wall, on the north and the south side, you've got the much higher peaks. So you really, in real life, you know that you're crossing the east portal. It's pretty obvious. So if you keep an eye on the airspeed here, as I cross over, there's a 35 knot wind blowing from the west, and so that's perpendicular to the north-south direction of the Rockies and of this ridge. And let me just get rid of that. And you'll see my airspeed begin to drop as the autopilot tries to maintain altitude in a downward moving column of air. And that's, something that's pretty common in the mountains. I had a friend of mine, he crossed the Sierras, also heading eastwards with a westerly wind, and it was at night in IMC, and he had the autopilot on, and it was a much higher performance plane, so it had a much higher stall speed. And his airspeed dropped fairly significantly before he noticed it, and it really freaked him out. So he told me that story, and I guess that maybe prepared me for this. So I get down to about 97 knots, and then disable the autopilot and put the nose down. And I need to descend down into Denver anyway. I've crossed the highest point of the Rockies now, and I'm on descending terrain. Need to get under the class Bravo. So there's 97 knots, and I think you'll probably see me disable the autopilot here. And so, back to the mountain wave effect. So that's the air flowing over the ridge and then downwards. And it's a laminar flow. At this point, I've got no turbulence. You can see the G meter in the top left is very calm. And I'm running basically full power, 28.5 manifold pressure. That's the dial just below the G meter. And just under 2,300 RPM on the prop. So I'm cruising along. I start my descent, and the mistake that I make here. So just to back up a little bit, as I was approaching the east portal, I knew that there was mountain wave effect going on because it was a 35 knot wind blowing perpendicular to the ridge, and then I saw lenticular clouds over the highest peaks. And I didn't check, but there might have been a temperature inversion this day as well, which accentuates the amount of turbulence that mountain wave will generate because it traps the wave below the high altitude inversion. Margaret Lamb writes about this in her excellent book on Colorado mountain flying. And if you really want to go deep on mountain wave, there's a book called Exploring the Monster, which is the history of gliding mountain wave. This is just a couple images that I've inserted here. This one is approaching the east portal, and you can see the cloud above the east portal directly above me here. And then the other image is a lenticular cloud. This is looking to the north. So anyway, I climbed up to 15,500 when I crossed the east portal to give myself more room because I was expecting a little bit of trouble. And as I get further away from the leeward ridge, I encounter some pretty gnarly turbulence. I guess in technical terms it would be moderate, where severe is your airframe actually starts falling apart. I don't think I was at risk of the airframe taking damage. The G meter is plus one additional G and negative 1G. I think that's kind of the swing. But we're going to get to the point where it hits me, and then I'm going to pause it, and I want to just show you some of the numbers, which are interesting. So again, I'm heading, sort of east-southeast away from the ridge, descending down to 13.8, and the G meter, you can see it's just very calm, very, very nice smooth air. And watch my VSI on the far right, it's 150. I'm supposed to be descending now. My nose attitude is slightly down. My airspeed is 143. This is much too fast. I should have slowed down much more in anticipation of this turbulence. So watch the VSI. So I actually start ascending there. I'm going to pause it here. Just take a sip of my tea here. But you notice how quickly the VSI went from negative to plus 650. The G meter is still pretty calm. I'm at 151 indicated airspeed. And we'll just do a bit of quick math here. So my true airspeed is 187 knots. So that's the speed at which I'm moving through the column of air. And if we then add a tailwind to that, we'll get my ground speed, which is 223. So what we can do is say 223 minus 187, and that gives me a tailwind here of 36 knots. Now you'll see that tailwind actually increases to about 40 knots at one point. So there's significant tailwind, and we'll talk about the vertical air movement in a minute here. I'm just going to continue playing, and this is at regular speed. Okay, so plus 850, plus 900, and wham, it hit me. So you saw I don't know if you saw the G meter there, but let me go back 1 second. It's plus, so I guess 0 on this G meter is actually 1G, in other words, at rest. So 0.53 is 1.53 in normal terms. So we'll go back another second. You can see it's 0.84. I'll just play from 2 seconds before. So there you saw it had like almost plus 1G. And so the VSI, so I'm in an ascending column of air now. I'm, VSI is plus 900, and my airspeed is still 151. Let's watch the airspeed for a second. 163 in a second. So from 151 to 163, and in 1 second later the VSI is at 1350. So I gained about 10 knots, and the plane isn't going to gain 10 knots. It can't accelerate that quickly. So this is wind shear from the front, and you can see the true airspeed. The ground speed minus the true airspeed is 17 knots. So I guess what happened is we saw a drop in the tailwind there. But indicated airspeed increased. So, wind shear from the front, I guess. And in a rising column of air, normally if you're climbing at 1,350 feet per minute, you don't gain airspeed. You'd be losing airspeed. So let's hit play. All right, very quickly up to 2,150. Airspeed's at 165. So we're increasing our airspeed, and we're increasing our ascent rate. And our true airspeed, or our ground speed minus our true airspeed, is 7 knots now. So some big changes there. All right, 3,350. That might be where it peaks. I guess I forgot to mention something else here, and this is part of the reason of the climb. But if you actually go back, you'll see that I start ascending before I pull the nose up. So let me just back up a little bit. So when I got hit really hard by this turbulence, I was going way too fast. So I immediately brought the power back. You can see the manifold pressure is 8.6. It's basically at idle. and I nosed up. I'm going to go back a few seconds here, and you can see, okay, so there's the G meter at 0.92, so that's me getting hit, and there was a little bit of activity before that, but then it was very calm. So let's just watch that G meter and the VSI. So so I start slowing my descent, a little bit of activity on the G meter, and you can see there's the column of air is ascending, and I'm still at 22 on manifold pressure. So I haven't pulled power back, and I haven't nosed up yet, but I'm in a rising column of air. All right. Then I get hit there, and what I do, you can see the power goes back immediately to try to slow down. I obviously glanced at the airspeed at this point, and I was at 150 a second ago, and I'm immediately seeing 162, and I'm like, oh man, I need to fix this. I'm going to damage this airframe. And obviously lots of regret that I wasn't going slower in the first place. So nose comes, so there I begin to pull the nose up. You can see the attitude indicator showing that, but I'm already in a 2,100 foot per minute ascent or climb. All right, and so obviously nosing up here, puts me in an even more rapid climb. So airspeed starts coming back. I'm really getting bounced around. The way this felt in the cockpit, it's, the G meter doesn't really capture it because, plus 1 G is nothing. I mean, we've all done 60-degree turns. That's 2 Gs. So that would be, in this G meter's terms, an additional G. And that's fine. What really made this difference or differentiated it is that the short and sharp nature of the turbulence. It was the kind of like rapid changes from positive to negative Gs. I was rolled a couple times, and I needed to rapidly correct, with ailerons. And it was very short and very sharp, and the high speed that I entered this turbulence at really didn't help. And feeling that short, sharp effect really creates a lot of urgency in you to slow the plane down. And so one of the things that I do here, so the one thing I got right is I crossed the ridge at 15.5. Great, okay. And I was talking to the Denver departure, and I actually let him know that I was crossing the ridge at 15.5 because of mountain wave effect. I might try to find that recording. But then what I got wrong was two things. The one is not slowing down on the descent and letting myself gain speed and entering this turbulence at high speed. And then the other thing that I got wrong you're about to see is I slowed down too much. So, I'm dealing with wind shear here. Watch the airspeed indicator on the left. It's at 100, and, it goes down to 86, 85, 84. I'm cringing as I'm watching this because, with wind shear, I could have a sudden gust from behind me and lose 10, 20, 30 knots and put me, I'm clean. None of my flaps down. And so put me pretty close to the point where the plane would stall, potentially induce a stall or a stall spin. The nice thing, though, is if you look at the AGL on the graph on the left there, it's 5,514 AGL. So I crossed at 15.5, and I was descending, but I'm descending over descending terrain. So I had a lot of air below me. And if I did enter a stall spin, I guess the one saving grace is that I would have quite a bit of recovery time. It would be challenging within already turbulent air. But so those are the two screw-ups here is and not slowing down enough to deal with this turbulence, and then overcompensating. At this point I'm still thinking, gee, I was going really fast. Gee, that turbulence was gnarly, and I haven't switched modes to got to keep air under the wings. So there's that. It's interesting, if you look at the attitude indicator at this point, it's pretty much on the horizon. But look at the VSI on the right, negative 3,100 feet per minute. So it's interesting. If you do the math on that, and you translate that into knots. And this is not something that normal, that instructors do that I've seen anyway. But if you actually wanted to know how many knots of wind that is vertically, a quick way to do that calculation is to just put a decimal point after the two digits to the left of the two digits on the right. So 31 knots roughly so the air is descending at a rate of 31 knots downward, if you can imagine that. Just to give you another way of thinking about how much wind this is, and if you look at the true airspeed is 113 knots. Look at the ground speed, 154. Let's go back to our calculator because I'm not too good at mental arithmetic, at least under pressure. So I've got a 41 knot tailwind, but then I've also got a downdraft at 31 knots, or, put in normal aviation terms, 3,100 feet per minute, negative 3,100 feet per minute. And, if you look at the altitude AGL here, 5,500. So, if you're a lot lower than I was, you could find yourself in the ground very, very quickly, surprisingly quickly. So let's hit play and see this continue. So I'm, increasing my airspeed here. I bring the power back up to 14. You can see the G meter is still bouncing around a bit. And I was pretty miserable until I got out of the foothills. At this point, I called up departure and said, hey, I wanted to report moderate to severe turbulence. And then later I revised that to just moderate turbulence because I didn't think that the airframe was necessarily at risk. But in the moment, it felt pretty gnarly. So I guess I increased the, my report a little bit, maybe a little bit too much. And looking at the G meter and what the airframe was exposed to, I think, and given that I'd been in the air for 3 hours already and I'd burned through a lot of fuel, I was very much within the envelope of what the plane could handle. But you look at the VSI, how much it's bouncing around, and that's just showing you how, as I'm moving through the various columns of air that are moving up or down at different rates, how much activity there is, and how much turbulence that's creating. So just to get back to the mountain wave discussion, what this is, and I've obviously I mentioned Margaret Lamb's book, and she has a great discussion about mountain wave. I did a brief sort of rescan of that section of her book before recording this, and I think the way she would describe this is trapped rotor underneath a mountain wave. I think the mountain wave is higher altitude, and it extends potentially 400s of miles over the plains, and I think that a lot of the mountain wave is fairly laminar, but underneath that, in the foothills, this turbulence happened at here you can see I get rolled a little bit. It happened at about 13,000 to 11,000, and so that's lower down, and that's rotor that is trapped underneath that laminar mountain wave. I think I'm no expert on this. I'm not a meteorologist, but based on my reading, that's what you're seeing here. And the actual mountain wave coming over the peak over the east portal where I crossed, and then beyond that, in that descending column of air, was incredibly smooth. But lower down, the stuff's getting churned up underneath that high speed wind, and when I crossed the ridge, it was a tailwind of 35 knots, but you saw a 40 knot tailwind lower down, which is interesting. So that's it. This is the third time I've recorded this, and it's helped clarify my thoughts on it, and I've kind of noticed different things each time I do this. On this day, just as another note, there was a report of severe turbulence from a TBM within the Centennial class Delta, which is quite far away from the foothills, but I think that was related to the mountain wave effect that was going on, and I experienced spotty turbulence as I got away from the foothills. It didn't go away; it just became more scattered, and I think that's probably what the TBM encountered as well. So, I guess the question is, all right, so what do you do? Well, firstly, be aware that you've got mountain wave. If it's 20 knots blowing perpendicular to the ridge, and when I say ridge, I mean when we talk about mountain wave, it's usually fairly big mountains. The big volcanoes, Mount Fuji, Mount Rainier, those will do it. There was actually, I think, an airliner that was ripped apart by mountain wave down in the lee side of Mount Fuji many years ago. And then also the Rockies, where you've got 14ers and you've got a north-south range of mountains. So if the wind is blowing perpendicular to that, let's say from 270 at 20 knots or more, and in this case it was 35, you're likely to have mountain wave effect. And then if you see the lenticular clouds, those UFO-looking clouds, Google them if you don't know what I'm talking about. That's a sign that you've got mountain wave. And we have that today. I'm recording this in Colorado on Saturday, December 14th, and driving to my office, it's very clear that there are lenticulars out. The wind speed is above 20 knots, and we've got mountain wave going on right now. And then a temperature inversion will apparently make this even more severe because of it traps the mountain wave below that high altitude temperature inversion. And then, like I said, additional reading on this. Margaret Lamb's Flying the Colorado Mountains is the Bible for this area. And then Exploring the Monster is a really, really interesting read on the history of glider flight in mountain wave conditions, starting off in Germany back in the 30s and 40s, and then extending to the Sierras and the research that went on there into the mountain wave effect. So I hope this is helpful for you if you're a pilot. That's really who this is targeted to. And I'll leave comments enabled, and hopefully I don't get a whole bunch of, well, you should have read the signs, or you kind of really screwed up there, pal, or whatever. So if you have anything productive to say, we'd love to hear your comments, or if you've experienced this at all, I'd love to hear what your experiences were. And fly safe out there.